Is your life also made a misery by batteries that are no longer up to the job? In this video, we examine the world of the lithium-ion batteries that power our smartphones and laptops. We find out what's inside them and how they work, and why, eventually, they tend to stop working.
Lithium-ion batteries are all over the place. They're in phones and watches and laptops, and near enough everyone in the UK uses them every day. But very few people know how they actually work. Lithium-ion batteries are made out of a positive electrode or a cathode, which is often made out of material like lithium cobalt oxide. They have a negative electrode or anode, which is often made out of graphite. The two electrodes are separated by a separator, which is immersed in an electrolyte.
When the battery is charged, lithium is held in the anode in the form of lithium metal. When the battery is supplying power or discharging, the lithium metal splits into a lithium ion and an electron. The lithium ion goes through the battery towards the cathode. The electron goes through the wire and provides power to the electrical device. The opposite happens during charging. The lithium ion migrates from the cathode to the anode, and the electron travels back through the wire. The reason this doesn't happen when the battery is off is because the electron can't go through the battery, it can only go through the wire because of the separator.
Here we see lithium-ion cells being built in the laboratory. These cells will use a simple lithium metal anode, but the cathode is formed from a powder containing nickel, cobalt, and manganese. The different components of the cathode formulation are precisely weighed. Carbon black is added to increase electrical conductivity, together with a binder to help hold the cathode together. The formulation is then mixed by hand. A liquid solvent is added, and the whole slurry of cathode materials is mixed for another 5 minutes, this time by machine. The mixture is then spread onto aluminium foil in a coating just 1/4 millimeter thick. It is dried out before being compressed in a roll mill. Individual cathodes can now be cut from the coated foil. Then they're ready to be combined with anode and electrolyte to form a completed cell. Beginning with the anode, the components of the cell are stacked in the casing. A fiberglass separator, soaked in electrolyte, keeps the electrodes from touching. The second half of the casing completes the sandwich of cell components, and a crimping machine is used to permanently seal the cell. The finished button cell is now ready for testing.
There are two main ways that your phone battery performance can decrease. One is through a loss of atom material, so that's either a loss of lithium or a loss of electrode material, which leads to a capacity fade, which means your battery doesn't last as long. And the other is through a power fade, which happens through just a slowing down of the reactions of the battery, which means that your battery and your phone or your laptop or whatever is much slower. Unlike a vintage red wine, batteries get worse as they age. So there's a couple of ways that this can happen, and they just happen naturally over time. But there's lithium plating, where lithium is reduced to lithium metal on the surface of the electrode rather than inside the electrode. There's SEI formation, which stands for solid electrolyte interface, where lithium forms complexes with the electrolyte, and that forms on the surface of the electrode again. And both of these impede the motion of lithium ions and actually take up the active lithium, and so the actual capacity of the battery is decreased and the potential power of the battery is decreased. The two main things that you can do are not fast charge your battery because it heats up your battery, which leads to an increased rate of reaction for any parasitic side reactions. The other one you can do is to not charge your battery too high, so don't charge it at 100% for too long. What you want to do is keep your battery somewhere in between about 80% and about 20%. Lower the number of complete charge-discharge cycles of the battery, which will help it last longer.
So, we've seen what batteries are made of, we've seen how they work, we've seen how to make them, and how to break them. Thanks very much for watching. Please check our website, and have a nice day.